Okay, this is graphs of radical functions, for example, square roots, cube roots, fractional exponents like 1/2. By the way, square root of x and x to the 1/2 are the same, just like cube root of x and x to the 1/3 are the same. So get an idea of what a function like this would look like. F of x equals the square root of x. I could plot some points. If I put -1 in here, square root of negative numbers are imaginary. Put 0 in, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9, put 9 in there, I get 3. Plotting these points, this means since square roots of negative numbers are imaginary, that means I'll have nothing on the left-hand side of the y-axis. So I got a point at 0, 0, 1, 1, 4, 2, and 9, 3. And connect the dots, and you get this shape that can be described as the top half of a sideways parabola opening to the right. And you do need to know what these things look like. I can graph these on the Excel sheet. So to graph equals the square root of x, you just type in equals SQRT of x. If I do that, I get a graph that looks like this. The reason it flatlines here is because Excel is confused because you're taking the square root of negative numbers. That's why it says num all over here, because we're taking the square root of these negative numbers. So the graph doesn't really start till 0. So if I graph it from 0 out to 9, I get the exact same graph I had on the beginning page. Now how about a graph like this? The negative square root of x. Well, let's take a look at these. To graph the negative square root of x, just put negative in front of the square root. And you get the bottom half of a sideways parabola opening to the right. And then the other one is the square root of a negative x. So the square root of a negative x. I don't see anything, so let's look over there on the other side. It's the top half of a sideways parabola opening to the left. So in general, you can use Excel to help you remember this, but this would be the top half of a sideways parabola opening to the right. This would be the bottom half of a sideways parabola opening to the right. So the sign outside tells you whether it's the top half or bottom half. Sign on the inside tells you whether it's opening to the right or to the left. So this negative here means to the left. This right here means it's the bottom half of a sideways parabola, because it's square root, opening to the left, and that's what that one would be right there. You can also graph these by using the 1/2 power instead. Like, for example, instead of saying the square root of that, I could say equals negative x raised to the 1/2 power, because 1/2 power and square root mean the same. So you get the exact same graph. Okay. What about cube root? How would you do cube root? Well, cube root is 1/3 power. There's no shortcut like letters to type in for cube root. So if I want to graph this function right here, the cube root, I would type in equals x, or you can keep it A10 if you like. That's here where the x's are, raised to the 1/3, because 1/3 power means, didn't type in the x. Because 1/3 power means cube root. So there you go. Sideways parabola on the right and bottom half sideways parabola on the left. So that's how you do those. If you have a messier power, let's do one a second. If you have something to the 2/5 power, really the safest way to do something like that would be, say, raise it to the second. Let's say it's going to be, again, 2/5 power. So you say raise to the second, raise to the 1/5. Do it like that. It's safer. If I do that, this is what something raised to the 2/5 power. Top half of a sideways parabola on the right, top half of a sideways parabola on the left. They're not quite parabolas, but they look like parabolas anyway. Alright, let's take a look at vertex points. How do you find vertex points? Well, just like we did with quadratics that are in parentheses, or absolute values that are in the absolute value area with the absolute value signals. With these, you just set what's inside that parentheses equal to 0 to get the x part of the vertex point. And the y part of the vertex point will be over here if there's no extra x. If there is, just substitute the x value back in. So let's get the vertex point for this. Set the 2x minus 1 equal to 0. I had to add 1 and divide by 2 to get 1/2. And then the y part of the vertex point is 8. So this vertex point is at 0.58. Now for the tough part. It says, what is the location of the vertex point? We got that, but what will make this function equal to 20? Well, to find out where it equals 20, you have to set the equation equal to 20. Now to solve this, just like you solve absolute value equations, you want to isolate this radical. So the first thing you want to do is subtract 8 to get 12 equals this. The 3 does not distribute 3. You got to get rid of the 3 by dividing it. So divide both sides by 3, and you get 4 equals this. Now you got to get rid of the fifth root. How do you get rid of the fifth root? Raise it to the fifth power. 4 to the fifth. You could do that on a calculator, or do it on Excel. Just do equals 4 carried up 5, and you'll get 1024. That gets rid of the fifth root, but now we got to get rid of the second power. How do we get rid of that? Take the square root. So taking the square root gives you 2x minus 1, and the square root of 1024 is 32. What a lot of people don't realize is not only do you get 32, but what else squared will give you 1024? Well, negative 32 does too. So this is like the absolute value where you get two equations here. Now solving both of these, you would add 1 and divide by 2 to get 16.5, and here add 1 and divide by 2 to get negative 15.5. So that's how you do that by hand. To do it on Excel, well, this is what we need to type in. We have to set the equation equal to 0. So move that 20 to the other side. So I'm going to go ahead and do that on Excel. So I'm going to type in, let me shrink this down so we can see it. So I'm going to type in equals, I'm going to type in the right hand side, which is 3 times this parentheses right here, 2 times x minus 1 close parentheses. Now this is squared, so I'm going to say raised to the second power. Now it's the fifth root, so I'm going to say raised to the, now the fifth root is not the fifth power. You see, square root is 1/2, cube root is 1/3, so fifth root is 1/5 power. So raised to the, now 1/5, put that in parentheses, 1/5 power, like that. One other thing you got to do, finishing this off, it says plus 8. And remember, we had to set this thing equal to 0 to solve it, so you subtract 20 from both sides. See, set it equal 0, so subtract 20. So the last thing is subtract 20. So now you have it in there, and we can take a look at the graph, and we see that that vertex point is down here somewhere. Where is that? Well, we already got the vertex point. It was at 1/2 and a negative, let's see, what was that vertex point? It was at 0.58. 0.58. Let's take a look at this here again. Oh, actually, yeah, I'm not graphing it. I'm solving it, so I can't be looking at vertex points when I'm solving it. When I'm solving it, then I just see it's different now. See, it says when is it equal 20. I'm not graphing this original function here, so I'm not going to get the right vertex point, but I am going to get the right solutions to where it equals 20. I set it equal to 0 when I typed it in, so now I'm just looking for where is this thing 0. This thing is 0 when it hits the x-axis, because that's when the height is 0. So when is this thing going to hit the x-axis? Well, farther to the right and farther to the left. Let's go farther to the right. Let's take a look at this thing maybe from 12 out to 20 or so. Well, there you can see that the one x-intercept is out here about 16 point something. So we can narrow in. Let's look at it from 16 to 17. And so it's going to be about 16.5. And the other one was over here somewhere, and between negative 10 and 20. Well, let's do here negative 20 and 10. I should say negative 20 and negative 10. And you can zoom in on it and hold the cursor there. It's about negative 15, between negative 16 and negative 15, negative 16 and negative 15. And here it is, right here in the middle at negative 15.5. And that's what we got when we did it by hand, those two solutions right there. So that will do it with the radicals.